So now it will be the fourth method from bases like NaOH or KOH. See what exactly is the situation. Metals like zinc, aluminium, etc. they react with NaOH and they form sodium zincate and liberate hydrogen. Aluminium, when reacted with NaOH solution, it forms a product sodium meta-aluminate and liberates hydrogen. So these are the metals: zinc, aluminium, beryllium, tin, considered to be amphoteric metals because they liberate hydrogen when they react with acid. They also liberate hydrogen when they react with bases like NaOH, KOH, etc. These are the different methods by which hydrogen gas can be obtained. On large scale, that means commercially, hydrogen gas is obtained by the methods in which water is allowed to react with carbon. In this process we get hydrogen and carbon monoxide. So that is the industrial method of preparation of hydrogen. Industrial method. In the industrial method, although it is a catalytic process, but water is allowed to react with carbon and the product is hydrogen and carbon monoxide. After this, the gases are separated and commercially hydrogen gas is obtained using this method. Now comes the properties of hydrogen. Properties. Diatomic molecular hydrogen, that is H2, is well known to have bond order 1. Its bond energy is high enough that hydrogen is a less reactive gas. Hydrogen is less reactive. Although it undergoes combustion, easily it undergoes combustion and it has a high calorific value. Means the heat evolved in the process per gram of hydrogen is a large amount. So we say that hydrogen has a high calorific value. Bond order is 1. Although bond order is 1, but still the bond energy is large enough to have lesser reactivity of hydrogen. Hydrogen in the molecular state has 2 electrons with opposite spin state. But hydrogen in the molecular state has 2 types on the basis of nuclear spin or the spin of proton. These are ortho and para hydrogen. Ortho hydrogen is said to be that hydrogen in which the nuclear spin of the 2 atoms is same. Para hydrogen is the sample which has nuclear spin of the 2 hydrogen combined together to form the molecule is opposite. I am talking about nuclear spin, not the electronic spin. According to Pauli's principle, the electronic spin is compulsorily opposite. But the nuclear spin is having 2 different possibilities in hydrogen. I repeat, ortho hydrogen has the same nuclear spin, or you can also call it the spin of proton, because An atom of hydrogen has a proton and an electron. When the molecule is formed, you have 2 protons and 2 electrons. So compulsorily the 2 electrons have opposite spin state, but the 2 new protons, they may have opposite or the same spin state. So in orthohydrogen, the protonic spin is same, while in parahydrogen the proton spin is opposite. Ortho and parahydrogen differ in their thermal conductivities. They also differ in their specific heat. So the difference of specific heat and thermal conductivity distinguishes the 2 forms of molecular hydrogen, ortho and para. Although the properties of the 2 forms will be same, the other properties I am talking about, chemical properties. Chemical properties of the 2 forms will be same, but they are different in some physical properties. Especially the thermal conductivity distinguishes the 2 forms of hydrogen. Now besides this, let us come to the chemical properties of diatomic molecular hydrogen. In the chemical properties, hydrogen undergoes combustion. Combustion of hydrogen means reaction with oxygen to form water. The important thing is liberation of heat. It has high heat of combustion. High heat of combustion of hydrogen shows that hydrogen is a good fuel. Hydrogen has a property to react with many of the metals. Reaction with metals. Hydrogen reacts with metals to form the metallic hydrides. These are the ionic compounds. Ca di positive and twice of H negative. This is an ionic compound. Metal hydrides. Actually this calcium hydride is called as hydrolith because it is used as a source of hydrogen. Just recall the reaction in which we have prepared, we got hydrogen gas from calcium hydride by the hydrolysis reaction. So there are many applications related to this. Calcium hydride is used as a source of hydrogen. The preparation of calcium hydride by this direct reaction also represents that the transportation of hydrogen, which is otherwise difficult, can be made easy in this manner. Hydrogen can be combined with calcium. It forms a safe compound, calcium hydride, and wherever hydrogen is required, by the addition of water in this compound, we get hydrogen gas. So this is the reaction with the metals, not only with calcium but with barium, magnesium. The reactions are possible. The reactions are possible. More common are the reactions of hydrogen with non-metals. With the non-metals, hydrogen forms various compounds like ammonia with nitrogen. The reaction is catalyzed by iron supported with molybdenum. Hydrogen also react with halogens like fluorine, chlorine, bromine, iodine. I have not balanced any reaction. In fact, all these reactions, they take place in various conditions, like this reaction is possible even in dark. This reaction takes place in presence of light. This reaction takes place when the two gases are heated when the two substances are heated, this reaction requires heating, and in fact the reaction is reversible. That means it does not undergo completion. These are the reactions of hydrogen that show the properties of diatomic hydrogen. Along with that, it has a reducing nature. The reducing nature of diatomic hydrogen can be shown with this. It reduces certain metal oxides to form the metal. Hydrogen itself undergoes oxidation to form water. A similar reaction can be given even for copper, oxide of copper. So we can have more number of examples. These are the reactions showing reducing nature of hydrogen. Hydrogen also converts unsaturated hydrocarbon into saturated. You know about alkenes and alkynes. The catalytic hydrogenation of alkenes and alkynes convert them into the saturated hydrocarbon alkanes. These are the different chemical properties associated with diatomic molecular hydrogen. Now, in the compounds of hydrogen, this was about hydrogen, its introduction, its general methods of preparation, properties including physical properties and then chemical properties. Now, in the next part, we have to include the compounds of hydrogen, in which two important compounds, one is water and another is hydrogen peroxide. They need to be considered in detail. Along with that, the compounds of hydrogen with non-metals, non-metal hydrides like ammonia, water, phosphine and different halogen acids, they are also included in our topics of P block, elements of P block. So that way we shall not cover up different types of hydrides in this part, rather they are covered up in the P block elements. But in this topic we have to cover up this hydrogen peroxide and water. Before coming to those particular topics, I mean the compounds of hydrogen, let us take a few questions from this part. Whatever part we have covered up till now, let's have some questions. Question is, give the products in the following reactions. Fine. In the first reaction I am taking NaOH with beryllium. Next I have taken HCl with calcium. In the next reaction I am taking KOH with zinc. In the next reaction I am taking concentrated H2SO4 with zinc, and in one more reaction I have taken dilute H2SO4 with zinc. Will you be able to tell me the products in each of these reactions? Try for all these. Tell me the products. Correct answers are Just like aluminium and zinc, we had given the reactions of zinc and aluminium with NaOH. That time I said it is possible to liberate hydrogen gas from NaOH by taking the metals like beryllium, aluminium, zinc, tin, etc. So one of such metals is beryllium, which liberates hydrogen gas when allowed to react with NaOH. The product formed Na2BeO2 is called as sodium berylate. This is sodium berylate. Calcium with HCl. It is an active metal, that means placed above hydrogen in the reactivity series. So here again we get calcium chloride with the liberation of hydrogen. Potassium hydroxide with zinc. Similar to this and similar to the reaction of NaOH with zinc, here we have potassium zincate. Had the compound been NaOH, the product is Na2ZnO2. Here the compound being KOH, the product is K2ZnO2, potassium zincate. Next to that, concentrated and dilute sulfuric acid. What do you think? Will they make any difference when they are allowed to react with zinc? I told you in between, that time I did not write the reaction since I had to ask this. This time you get zinc sulfate but not hydrogen, because in the next reaction you get zinc sulfate and hydrogen, but in this reaction you don't get hydrogen. Rather, the hydrogen is oxidized into water and sulfuric acid itself is reduced into SO2. So could you understand why do we get the difference in the product here? It is due to the fact that concentrated sulfuric acid has oxidizing property also. Concentrated sulfuric acid is an acid, but it is also an oxidizing agent. Dilute sulfuric acid is an acid but not an oxidizing agent. That is why we have a difference in these two products. Now tell me one more thing. Taking HCl or taking dilute H2SO4 with zinc, we can obtain hydrogen. Is it possible that hydrogen gas is liberated when dilute H2SO4 is reacted with copper? Is it possible? Answer is no. If copper would be there, hydrogen gas is not liberated. Can you think about the reason? Yes, the reason for this is position of copper in the reactivity series. The position of copper in the reactivity series is below hydrogen, while that of zinc is above hydrogen. So the reaction which is possible with zinc and dilute H2SO4 is not possible with copper and dilute H2SO4. So we should keep in mind certain things conceptually, so that the reactions can be observed, they can be mentioned wherever required. This usually happens that we start counting the reactions, so many reactions, how to learn, what to do, but it is always better to focus on the concepts. Why do we get hydrogen when metals like beryllium, zinc are allowed to react with NaOH? Because they are capable of forming the salts, this kind of oxysalts. They have a property to liberate hydrogen from the bases also. They are active metals of a specific category. So, by the conceptual approach, you will not require the reactions to be mugged up. By the conceptual approach, you can understand the reactions and then you can give the answer on that basis. In the next part of the topic, I am including compounds of hydrogen. So at the introductory level and for hydrogen, I hope I have covered up almost all important points, and in the compounds Once again, as I said, I shall mainly consider and take water and hydrogen peroxide, the important things related to these compounds. The hydride compounds will be included in S and P block elements. Thank you.